Hello dear students, today we will solve one problem based on the capacitors. This problem is basically from NCERT book. This problem is very good. So the problem is like this: an electrical technician requires a capacitance of 2 microfarad in a circuit across a potential difference of 1 kilovolt. A large number of 1 microfarad capacitors are available to him, each of which can withstand a potential difference of not more than 400 volt. Suggest a possible arrangement that requires the minimum number of capacitors. So we will proceed for the solution. The problem is like this. If you will see the problem, it is an electrical technician requires a capacitance of 2 microfarad in a capacitor. So total capacitance in a problem required is 2 microfarad. So here total total capacitance. First we will write the given data. What given data we have? Total capacitance required in a circuit in a circuit and I am representing it by C2. It will be, it is given in the problem, and it should be 2 microfarad. Now it should be 2 microfarad. Now in a circuit across a potential difference of 1 kilovolt. So given supply voltage is given given supply voltage is 1 kilovolt and it is equal to 1000 volt. Now it is 1000 volt. So now a large number of 1 microfarad capacitors are available to him, each of which can withstand a potential difference of not more than 400 volt. You can see in the figure, a large number of 1 microfarad capacitors are available to him, and the voltage around this 1 microfarad capacitor should not be more than 400 volt. Okay, so now, and we have to suggest a possible arrangement for this problem that requires the minimum number of capacitors. So we have to suggest a possible arrangement that requires the minimum number of capacitors. So now we will proceed for the solution. So now, as you can see, and capacitors are arranged in are arranged in M rows. That is, if you will see the circuit diagram here, N capacitors are arranged in M rows. Just see, this is first row, this is second, this is third, and we don't know how many rows are there. Okay, just a general description is given in the given figure. Small N capacitors in M rows. So we will proceed for the solution. So here N capacitors are arranged in M rows. So we will write it mathematically. So total number of capacitors. So total number of capacitors are given by capacitors are given by capital N is equal to small n capacitors in small amperage. So it is given by capital N is equal to m amperage. So here if m is 1 and n is 2. So total number of capacitors in one row will be 2, and you can just verify from the figure given below. Just see here, 2 capacitors in first row. So in this way we have written it through the help of mathematics. So total number of n capacitors in amperage. So now we will proceed further. So here, and if you will see clearly in the given figure, here capacitors are, that is these 1 microfarad capacitors in amperage, they are connected in series. So now we will proceed further. So here when capacitors are when capacitors are connected in series combination, series combination there are some important concepts behind series combination. I am writing all those important concepts in points. The first is the same charge. What is the same charge flows through each capacitor, each capacitor. And second is the total voltage, the total voltage divides among the capacitors. And last is last point is the sum of voltage across each capacitors in series is in series is in series is equal to the total voltage applied. So these are the important concepts behind series combination. Now we will come to our problem. Then the total voltage, we will calculate the total voltage the total voltage across each capacitor each capacitor is equal to total voltage power supply, total voltage upon total voltage upon number of capacitors, number of capacitors. So now we will proceed further. So here total number of capacitors is small n, and given voltage power supply is 1 kilovolt, that is 1000 volt. So we will proceed further. So here it will be 1000 upon n volt, and in our problem it is given that each of the capacitor can withstand a potential difference of not more than 400 volt. So here we will use this concept, those we will use this condition in our problem. So now we will proceed. So here this, it should not be greater than 400 volt. So it should be less than or equal to 400. Now we will calculate small n here, number of capacitors. So it will be equal to, small n is greater than or equal to 1000 upon 400. So here n should be greater than or equal to 2.5, which implies n is 3. So here minimum number of capacitors is 3 across each rows. Okay, so we have got this minimum number of capacitors across each rows should be 3. So here if you will see the figure, so here there should be one more capacitor in each row. There should be 3 capacitors in each row. So here we have got our small n as, that is minimum number of capacitors should be 3. Now we have to calculate the value of small m, that is rows, and if we will get the value of small m and n, then we will get the value of total number of minimum capacitors, that is capital N, and it is mn. So now we will proceed further. So here we will proceed further. So now we will calculate now net capacitance of each row and each row, and there are 3 capacitors along each row, and we know from the series combination 1 upon C1 is equal to 1 upon 1 plus 1 upon 1 plus 1 upon 1. So here 1 upon C1 is equal to 3 and C1 is equal to 1 upon 3 microfarad. So now we will proceed further. So here, if you will see the capacitors clearly, all these capacitors are connected in series combination, and all these rows are in parallel combination. So now, so C2 is equal to, I am denoting the net equivalent capacitance of the circuit by C2 is equal to M C1. That is, all these rows, that is M rows, are in parallel. So I am calculating total capacitance of the circuit, and it is equal to C2 is equal to M C1, because parallel combination is C equivalent is equal to C1 plus C2 plus C3. If you will calculate total capacitance across each row, that is M is equal to 1, 2, 3, then you can verify this mathematics. This is simple basic mathematics and nothing else. Now, and for parallel combination, we simply add all the capacitors. You know all this. This is basic. So now, from here, C2 is equal to M C1. We know C1 and C2. Then we will calculate small m. M is equal to C2 upon C1. And C2 is given total capacitance of the circuit, and it is 2 microfarad, and C1 we have calculated this, it is 1 upon 3 microfarad. So here M will become 6. So here we have got minimum number of rows should be 6, and 3 capacitors are arranged in each row. So total number of capacitors, capital N, will become 6 into 3, that is 18. So we have got total number of capacitance, and it is 18 capacitors. So this was a little bit tricky problem, but if you will solve this problem, you will enjoy. So here we have got minimum number of capacitors, and it is 18. So 6 rows are needed for this, and in each row 3 capacitors are connected, and total capacitors are 18, and it will give a capacitance of 2 microfarad, and this was the problem. So this is the solution from my side. If you like my problem solving technique, then please like, share and subscribe my YouTube channel. That's all. Thank you.